All right, today we're going to graph systems of inequalities. So let's remind ourselves, what is a system? Okay, a system just means two or more equations. Now, our equations today are really going to be inequalities. So it's going to be putting together a bunch of stuff that we've done together all in one. So let's get after it. Okay, so look at our set for our first set here. It says y plus 2x is less than or equal to 4. So we want these to be in slope-intercept form, so they're easier to graph. So let's move this over and make this work for us. We're going to move that 2x over here, so y is by itself. So I'm going to have y is less than or equal to a negative 2x plus 4. That one's easy enough to graph. But now look at this one right here. Negative 2y is less than negative 2x plus 6. I need to get that negative 2 gone, so I need to divide through by negative 2. Please take the time to write the step out. When I do that, that becomes 1. Now, when you do this, this is where the inequality switches. Because I've divided by a negative number, I have to switch my inequality to a greater than now. Now over here, negative divided by negative is a positive. This can be positive 1x minus 3. So here's my two equations I'm going to graph. Y is greater than x minus 3 and y is less than or equal to 2x minus 4. But I just want to stop and have you remind yourself. Anytime if you divide or multiply by a negative number, flip the inequality. It's really important that you do that. It changes the way you shade, right? Which was going to change your solution set. So be really, really careful. Now back to our question. Let's graph these. So the first one has a y-intercept of 4. So I'm going to make my y-intercept here. It has a slope of negative 2, so I'm going to go down 2 over 1, down 2 over 1. All right, from here I'm going to draw a solid line because it's an or equals to inequality. And then I need to shade according to the inequality. Well, the inequality is a less than, so I find my y-intercept and I'm going to shade down. So this area down here is going to get shaded. Now, let's do the second line. The y-intercept on this one is negative 3. Negative 3. And the slope is 1, so it's up 1 over 1, up 1 over 1. This one has a dotted line, and it looks like that. Now, if I find my y-intercept, I'm now going to shade. So notice I'm shading lightly, and I'm going to shade over some things that are already shaded. So this one is greater than. So I'm going to shade above. So this section that has been double shaded, red and blue, this is where my solution set falls. Anything within this will be a solution to both equations. So would 0, 0 work as a point in the solution set? Because notice our instructions here, guys. It says to graph and name a point in the solution set. The easiest point to name, if you can, is 0, 0. So let's see, would 0, 0 fall within the double shaded region? It does. So I would say solution point 0, 0. All right. Now when you're shading with a pencil, you should be able to tell where you've double shaded, okay? You want to make it obvious, but you don't want to tear your paper up, okay? Make it obvious. Let's try another one. Number 2. Let's see if we're in slope-intercept form. Well, this first one needs a little bit of work, so let's rearrange a little bit. Negative 4y is greater than negative 2x plus 4. Now, we need to get rid of the negative 4. Divide by negative 4. So y, remember this is where it's going to change because I'm dividing by negative, is less than now a positive 1/2 x minus 1. All right. This one is in the correct form to graph it, so we're good. Notice, however, I want you to see this. Look at the slopes of our lines. Do you see that this has a slope of 1/2 and this one has a slope of 1/2? Do you remember what that means? Hopefully you remember that means these lines are going to be parallel. But let's graph it and see what happens with our shading. So if I take that first line, it has a y-intercept of -1. It has a slope of up 1 over 2. All right, it's a dotted line. Over 2, down 1, over 2, down 1, going this way. So it's going to be a dotted line. And it's a less than, so I need to shade below, take that y-intercept and go below, it's less than. Now if I go to the second line, it has a y-intercept of 5. Right there. And it is going to be up 1 over 2. Same thing down, going this direction. But this one is dotted as well. Now, where am I shading here? Well, this one says to shade greater than, so it's shading above. So notice there are no points that work for both lines because there's no overlap going on. We have no overlap, so this is a situation where we would say there's no solution. Okay, no solution. Now, don't make the assumption that just because they're parallel lines, there's going to be no solution. That's not always true. I could have had to shade below this one and there would be overlap, or I could have shaded above this one and there could have been overlap. But just because they're parallel lines does not mean there's always no solution in this scenario when we're doing inequalities. All right, let's try this last one. This is really what we're getting after because we're going to do some absolute values in here and see if we can find a solution for this system. Okay, so let's look at our equations. Thankfully, they are already set up for us in the correct format, so we don't have to do any rearranging, but let's graph these. All right, first equation has a y-intercept of 4, and it has a slope of 1/4, so up 1 over 4. And it is a solid line. Okay, and I would shade on this, I would shade, it says less than, so I'm going to take my y-intercept and shade less than. I'm just going to do some stripies, okay? Now let's do the second equation. Y is greater than or equal to the absolute value of x plus 2. So that's taking my vertex and moving it left 2, 1, 2. And then I have a slope of 1. So I'm going to just go up 1 over 1. All right, so it's a solid line because it's greater than or equals to. So I'm going to draw my solid line like that. And let's shade. Let's look at our shading here. It says greater than, so go to my y-intercept and I'm going to shade greater than. So I'm going to be shading the inside of that triangle. Okay, I can shade all of this. All of this gets shaded, but notice the overlap is just the inside of the triangle. Now that last equation is y is greater than or equal to 1. Well, that's a horizontal line where y is 1. Horizontal line where y is 1. All right, and where am I shading now? Well, when I shade that, it says greater than, so I'm going to be shading up above y equals 1. So I'm looking at where is this thing triple shaded? Well, hopefully you can see that this thing is triple shaded in this triangle right in here. Above that black line, but in there. So when I pick a solution point, I can pick any point in that area. I can even pick points on the lines, because notice these lines are solid, so any point on those lines would be a solution, as long as it's in the shaded regions. Now, let's just pick a point, make it simple, and call it this point right there. So what is that? -2, 1? That'll work. So my solution point, -2, 1. Now you and your neighbor may have different solution points. That's okay, as long as it's in the shaded area. Now when you do your work, do it neatly so I can see where you're shading, especially when they get into overlaps. Make sure it's nice and neat, and I can grade your work carefully, because you may pick different points than I do. So hopefully this makes some sense to you, and you'll let me know what questions you have.